This is quick tutorial for our project. Our project consists of three elements: Arduino and switches and motor control circuit. We have three switches, 1, 2, 3, and one Arduino and one motor with control circuit. First, we discuss what's the difference between this switch and this push button. This switch, when I press in this switch like that, after release my press, the switch not returned to the first position. But here, after I press and release the switch, it automatically returns the first state, like a keyboard push button. We just generate one signal and then return. So we will use this switch for power on off. This switch will be like that. This on off. You press here, one press, and it is not returned automatic to first state. But the push button, like that, like this one, uh, we press one press and then automatic return to first state. So when I use this one and when I use this one, I use this one if I need to multifunction for this push button. For example, if I press first signal, I use to move motor forward, and second signal move motor backward, and third one is stop motor. This now I use three function for one push button, but this just have two function, on and off. So after you connect the battery, you will connect this switch parallel with battery to on off the power for Arduino circuit. This our on off control and our first function we use. I will talk a little about a problem we will face, because when the power off, the motor will forget the last position. So this problem, I need to connect the power every time to the Arduino. Just the power is cut off in Arduino, the program will start from begin or begin from start. Then the motor forget the position. So we will get solution for this problem. Advanced solution if you want that, to save the position of the motor in EEPROM. EEPROM is the memory in Arduino, in microcontroller. We can save the last position for motor. So if the power cut off, the motor will remember the position after the power returned. So we will talk in this point later, but now we just tutorial about our project. Our project will consist of this switch, and as I see, this just on off the power from motor. Then this switches, this first switch, this control reverse and forward for motor, or backward and forward for motor, by generate signal 1, signal 2, and this one will return motor to a 0 position. Okay, I connect this first switch to this point pin. Switch 2 connected to Pin number 4, switch 3 connected to pin number 5. If you want to change this in this code, switch 2 connect with 4, switch 3 connect with 5. If you want to change it, just change here in your code, change the connection here. This switch 4, you can delete it from the code. I just write it but not use. Okay, return to here. Also, I connect the power circuit. This is your power circuit or power control for motor. Just here. This, if you know this ULN 203, this is PMP transistor. Just control the ground for the motor. We won't talking about these details, just we talking about the connection. I connect it for 8, 9, 10 and 11. You can change it here in hardware, and you need to change it here in software. This your code 8, 9, 10, 11. If you reverse it, for example, you write here 11, 10, 9, and 8, the motor will reverse the direction. So you can reverse the direction of motor by reverse the connection here. It's okay. Now we discuss our motor by talking in datasheet. First, this we will control full step control. What full step control? Quickly, the motor have 4 coil like that. This coil A, P, A dash, P dash, or A, B, C, D. This magnetic field, the rotor magnetic field, when I active the A coil, the magnetic field will go to A, to first position. So if I active B, the rotor will go to B, and if I will active C or A dash, this arrow or the rotor will go to the A, and if I active D, also the rotor will go to D. So just the important information. The important information. If I active A and B at the same time, what the motor go? Will go between A and B. So I need to motor A, then the motor come here to this point, then B. This mean full control. Full control step. Full step control. I can A, B, C, D, just 4 signal. I active A, then I active B, then I active C, then I active D, but I don't do that in the software. I do active A, then active A with B at the same time, so the motor will go here. Then I active B only, sorry, I active B only, so the motor rotor go here. Then I active B with A dash or B or with C dash, then the motor go between and then active just A dash or C. So the motor will come as you see here and go on. So this need 1, 2, 3, 4, 5, 6, 7, 8. This 8 step. So I do that in the code. You can see here our matrix here. Low, 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 high. This one, number 1. Low, low, high, high. This number 2, and low, high, low, like that. And you can return to this figure if you want to understand why I write this eight signal or eight matrix. 1, 2, 3, 4, 5, 6, 7, 8. This eight number of array. So this our control scenario. We want to control the motor. This first write this step matrix to control steps for motor. Okay. Now, also important information from datasheet. Here, every step control this angle, and the motor have reduction gear 64. So, how I calculate the number max, the one revolution continue number of steps. One revolution have 360 degree. This one for one revolution. I divide it by the step, the angle of a step, this one, and I multiply for gear ratio. If you do this calculation, you will get this 496. So I write here this mean number of steps, total number of steps, because I generate every clock one step to control the motor. So I need the total number of step is this number. You can change it according to motor, but you don't need to change this one because we use already your data sheet and you already use the same motor and the same number. It's okay. You will connect, just connect this to Arduino and connect this one to motor. Then it's okay. This here the motor have 6 terminal, 2 ground or 2 common, and 4 to control. This 1, 2, 3, 4, and another 2. This is the same in if you see your data sheet here. This 1, 2, 3, 4, pink and orange. This 1 and 2, yellow and blue. This 3 and 4, and orange and red is common. We connect it to power or 5 voltage. You will use cable automatic, and you don't need to array this terminal. Just connect, plug and play. It's okay. Now anything in our Arduino? Okay, if you need to change this connection, just connect as you want hardware, and then here you need to modify this software like here. It's okay, we can start now our project. This not simulation, because here power is connected automatically to Arduino, but you need to do this in your circuit. Take your battery and switch, not push button, because push button I just push one button and it return to the first state, but here I need to one fix it in state like that. I on and off. Okay, start the simulation. Here I want to zoom here. Now motor in 0 position. I will press one press and release like that. One press. Motor continue or return, rotate in forward. Is this a minus? You can say it backward, no problem. Left or right? Oh, now this 316 and 60, this is the position of motor, and then stop. We can make it return automatically, but I think you don't need that. So I need to return by press this push button. The motor stop because my computer just hang up. But in real, when you download this code in your circuit, you don't see the motor hang up or stop. Now the motor in zero position. I can press again for switch to the motor return. I can control the motor speed, and I will see you how to control the speed of the motor. Now the motor stop in the right position. I can press again and press again and press again. Now I need to the motor to go to the zero position. I click here for the position of the motor. Now motor go to the 180 degree, but this number not accurate. You will find your motor accurate 180 degree. Uh, Now I stop the simulation, and here I will see you how to control the speed of the motor. Here is time delay between steps. Uh, if the motor, uh, 1 minute, here is photo. This photo. This first step, second step, third step, fourth step. The time between every step I can control. This will mean that I control the speed. Is this long time? This mean is low speed. Is this short time? Is mean high speed. So if you see the motor is very speed or speed is high, you can large this value by like 10 or 100. This is time in millisecond. Time in millisecond, and I can you can see it here. Delay, time delay. This time delay automatic 10 millisecond and 100 millisecond as you want to control the speed of the motor. Also, also about connection. Now it's okay. It's okay. We can make the program more advanced if you want to change anything like direction, or like to save when the power cut off the motor is remember the last position. It will be easy. No problem. We can save the position as I see before in the EEPROM, so the motor don't forget the last position. And I hope this is useful for you. And if you want anything again, just tell me. And if you need to modify your circuit, if you don't understand anything, just tell me. Thank you for your time and consideration.